In this opportunity, we are going to talk about real estate terminal values. In a previous video, we argued that the traditional approach for valuing income properties was incompatible with the risks associated with the different cash flows that compose the free cash flow. We propose an alternative procedure that discounts each cash flow category at its corresponding discount rate. In this presentation, we will follow the same approach to estimate the terminal value when it is assumed that the terminal value is a present value of a growing perpetuity. At the time of estimating terminal values, we have mainly three main possibilities. The first one is to estimate the terminal value as replacement cost. So we estimate how much it would cost to replace the property at the end of the horizon, and then we adjust this value with the depreciation of the property throughout the horizon. The second alternative is multiples. We just value the property at the end of the horizon using a multiple such as the gross yield. And the third one is the perpetuity. In this presentation, we will focus on perpetuities, which, by the way, tend to be the most usual, the most popular at the time of doing evaluation. Given that we are thinking of the cash flow as composed of different cash flow streams at different risk, in this case of the perpetuity, we can separate these cash flows into the following components. First, something that we will call the adjusted potential gross income after the horizon, that I will explain in more detail later. Second, periodic expenses and recoveries. Third, major maintenance. And fourth, integral refurbishment costs. But basically, the adjusted potential gross income includes all the cash flows which are closely correlated with the rent. The second one, periodic expenses and recoveries, include all these cash flows which are perfectly predictable, yearly cash flows, okay? That includes expenses and recoveries, which usually are discounted at the risk-free rate. Major maintenance is the maintenance that we have to perform in a property with a certain frequency. These are major expenses which are not performed on a yearly basis, but maybe every 5 or 10 years. And finally, integral refurbishment is when we practically reconstruct the property after, say, 30 years. This includes a very complete, rebuilding of the property. So let's analyze each of them. First, adjusted potential gross income. Basically, it represents the present value of potential gross income, and then to this we add other income, and we subtract losses and taxes. As we said in a previous video, these are the cash flow streams which are closely correlated with the rent. And we will call this adjusted potential gross income IGPA. We will assume that this stream grows with inflation in perpetuity. And we will also assume that the growth rate, usually assume that the growth rate is equal to the inflation index. So the formula is simply the present value of a growing perpetuity. The present value at time n, meaning at the end of the horizon, of this adjusted potential gross income is given by IGPA, that is adjusted potential gross income in 1 year after the perpetuity, that is in year n plus 1, divided by the gross yield. And remember that in the case of a growing perpetuity, the gross yield is expressed as R minus G, where R is the discount rate and G is the growth rate that usually we assume is equal to the inflation index. The second component, expenses and recoveries, is basically periodic expenses and recoveries after the horizon that will grow at a certain rate, again, usually inflation, and we discount at the risk-free rate. Here we are including recoveries together with periodic expenses. But remember that in a previous video we said that possibly recoveries could be discounted at a rate which is not the risk-free rate, but a rate that is somewhere between the risk-free rate and the gross yield implied rate. In this case, for the sake of simplicity, we are going to put them together and discount them at the risk-free rate. The third component is major maintenance, and here we also will include integral refurbishment. Well, let's start with integral refurbishment. Remember, integral refurbishment are very complete, changes in the property, that you make every 30 years or so. It's practically rebuilding the property. And we are going to assume that refurbishment takes place every T years, say every 30 years, for instance. And that the first refurbishment takes place at year M after the horizon. So if the horizon, say, is N years, say it's 20 years. M, the date of the first integral refurbishment, we assume that, for instance, this is year 30, meaning 10 years after the horizon. So M will be equal to 30 in this example. And then we define as the refurbishment cost at time M, at the time of the first refurbishment, in nominal terms, it will be equal to CIRM. It can be shown that the present value of the refurbishment cost at time N, meaning at the end of the horizon, will be given by this formula. So the present value of integral refurbishment at time N, meaning the end of the horizon, is equal to 1 over 1 plus the risk-free rate to the M minus N, okay? And M is the time of the first refurbishment and N is the time of the horizon. Then we multiply that by CIRM. CIRM, remember, is the cost of the first integral refurbishment at time M. This multiplied by 1 minus the corporate tax rate, and we divide by 1 minus 1 plus the growth rate, which usually is equal to inflation, growth rate, divided by 1 plus the risk-free rate, and all this to the T power. And T, remember, is the frequency of the integral refurbishment, for instance, every 30 years or so. Well, if we want to get the formula for major maintenance, it's pretty much the same procedure. Okay, the major maintenance also takes place every certain number of years, so we can use exactly the same formula for a major maintenance. Okay, it's exactly the same idea, but of course the parameters are different. Let's illustrate with an example. Say that we have a property, the horizon is 15 years, so this is N. Adjusted potential gross income in year 16, so for the first year of the perpetuity is 5 million. This includes, remember, the potential gross income plus other income minus losses minus taxes. The corporate tax rate is assumed equal to 30%. The gross yield is assumed equal to 7%. Expenses and recoveries are assumed to be equal to 120,000 in year 16, so the first year of the horizon. Major maintenance is assumed to be equal to 2 million in year 15, so that is the same year of the horizon. So we are assuming that the first maintenance takes place at year N, the same year of the horizon. Integral rehab is 25 million in year 30, so we are assuming that the first integral rehabilitation takes place 15 years after the horizon, meaning in year 30. Year 30 is year M in our formula. Well, the risk-free rate is 5% and the inflation rate is 2%. So let's do the computations. First, adjusted potential gross income. Well, we calculate the present value in year N at the end of the perpetuity. At the end of the horizon, I'm sorry. And the formula is this formula that I showed you before. So the present value in year N, year 15, will be equal to adjusted gross potential income in year 16, that was given as 5 million, divided by the gross yield, which was given as 7%. That will give us the present value of the adjusted gross potential income in year 15, 71,428,000 29,571. Well, the next step is to bring that value to present value, so to year zero. To do that, we discount this amount, 71 million plus, at the gross yield implied discount rate. What is the gross yield implied discount rate in this case? Well, the gross yield is 7%, the inflation rate is 2%. Remember then that the gross yield implied rate will be the sum, 7 plus 2%, 9%. So 19,609,860 is the present value of 71,428,571 discounted over 15 years at a 9% rate. Now let's go to the other items. First, expenses and recoveries. We know that expenses and recoveries were 120,000 in year 16, so we just discount that to year 15, assuming that it is a growing perpetuity, growing at the inflation rate, and we apply this formula here. Present value, it will be equal ER divided by RF minus G, and we obtain 4 million as the present value at the end of the horizon, 4 million. Major maintenance is, we just apply the formula that we saw before, the long formula that we saw before. In this case, given that major maintenance takes place, the first major maintenance takes place in year 15, so the same year of the horizon, we don't have to discount from year M to year N. So the formula is simplified to this one here. And 15, which is the value of major maintenance in year 15, 2 million, multiplied by 1 minus TC and divided by 1 minus 1 plus G, 1 plus RF. And the power 10 represents the frequency in which we do major maintenance. So in this way, we obtain the present value of major maintenance in year 15 as 5,563,433. Finally, integral rehabilitation is exactly the same procedure. We plug in the cost of integral rehabilitation in year 30, which is the first year we do integral rehabilitation. We know that that is 25 million, multiplied by 1 minus TC, divided by 1 minus 1 plus G, 1 plus RF, and the exponent is 30 because 30 is the frequency of the rehabilitation. Given that the first rehab takes place 15 years after the horizon, then we have to discount that by the risk-free rate over 15 years to obtain the value of integral rehabilitation in year 15. In this case, the number is 14,491,166. The next step is to add all these amounts, which are discounted at the risk-free rate. We add them up and we discount at the risk-free rate from year 15 to year 0. And we obtain 1,570,674. Well, the present value of the terminal value at time 0 will be simply the difference between these two amounts. Will be the present value of adjusted gross potential income, which is 19,609,860, minus the present value of the outflows, which is 11,570,674. And the result is a present value of the terminal value at time 0 of 8,039,186. Conclusions. Well, in this presentation, it has been shown how, when represented as a growing perpetuity, the terminal value of an income property can be estimated as the sum of 4 perpetuities. The adjusted potential gross income, as we defined it before, periodic expenses and recoveries, major maintenance, and integral refurbishment costs. Well, and that is all I wanted to share with you today. Thank you.